Hmm. We are live. Yes. Hmm.
I give a minute.
Hmm. Okay. So, hey guys, how's it going? Like everyone who has joined the live stream, how's everyone doing? Or hi, Honey Kumari. Other people also give me a loud cheer in the comment section if you guys are watching this live stream or like आप लोग कहाँ से देख रहे हो ये live? Maybe just let me know. Okay. So, like, seems like the participants, Harshil has said hello. Hi, Harshil. How's it going? How are you? Okay. Maybe we can start in the next 2 minutes so that more participants can also join. And then maybe we can begin with the webinar. We'll start the session at 7:10. Okay, I think we should start with the webinar now. So, good evening, everyone. Welcome to KodeMaster AI Expert Live Series, powered by Genesis. For those who don't know me yet, I'm Divya Tripathi, and I'm part of the Genesis team, and I'm working as an AI engineer at KodeMaster AI, and I will be your host for today's session. Now, let me start with something really simple, like a very basic question. Why are you actually here today? I mean, seriously, think about it for a second. You guys are giving us your valuable time and watching this webinar. Why have you joined this session? Are you here to learn another framework or any other boring pattern or another coding trick or another shortcut? Or are you here because you feel like something big change in tech is coming right now? Because let's be honest, AI can write code. In this era of AI can help you in writing code, it can build APIs, it can scaffold projects in minutes. So, if code is becoming easier to generate, what actually makes an engineer stand out? Is it speed? Or is it the ability to think about system? Like what legit separates a demo project to a real life project that is being used by enterprises in their real world applications? What happens if traffic spikes, or what happens when service crashes? Is your app suddenly able to handle the load of 50,000 users? I mean, to answer all of these questions, to make you ready for an enterprise or let's say industry ready engineer, we have hosted this webinar. And that's what today is about. Today is not just about writing code, but understanding how systems behave in the real world. To help us unpack these questions, two incredible and amazing engineers have joined us today. First, we have Mr. Vijay Ganesan, who is working as a principal software engineer at Mastercard in the United States. He works on large scale financial systems where reliability is not optional, it's critical. Vijay, we are really glad you could join us today. How are you doing?
I'm doing excellent, Divya. Thank you so much for hosting me. This is very exciting to be here, and I mean, it's like beautiful morning here in US. Hope you guys are doing well in like India as well. And I'm like really excited to join here and like talk about which I'm like very excited to because like day in day out I like work on a systems which like demands this like large scale systems. So this like topic is very close to me. So like thank you so much for just like inviting me here.
Yeah, we are really glad that you could take out time from your busy schedule and become a part of this webinar. And let me be really honest, I'm very excited to get your perspective on these certain topics. And to adding to this panel of amazing speakers, we have Srinjoy Das, the founding engineer at KodeMaster AI, who has been focused on building hands-on system level learning experiences so engineers don't just ship features, they understand architecture. Srinjoy, great to have you here. How are you?
I'm good. Likewise, Divya. It's a pleasure to be here. Thank you for inviting me to this webinar. I'm really excited how we are gonna discuss about this core fundamental topics to become a really good engineer in this AI era. And yeah, looking forward to it.
Awesome. We are glad that we both of you are here today. So, let's zoom out for a second. In this era of AI, information is not the problem. You can learn anything online. You can build projects within an hour with the help of AI assisted coding. You can learn, or let's say, watch tutorials all day. You can even get AI to explain concepts instantly. But what do you guys think? What's harder? Or let's say, what separates a senior engineer from a junior engineer in today's world of AI to get them industry ready? What do you think are the key skills which are legit needed to make someone industry ready from either from a software engineer perspective point of view or from an AI engineer's point of view? Like I would love to hear first Vijay sir's point of view, considering his expertise in this and since he's working on this on a daily basis at a company like Mastercard. Uh, Vijay, you're not audible.
Oh, sorry. Sorry about that. It's all right. That's a great question, and honestly, we are all just like figuring it out. Just no matter what, it's like small company or like big companies. AI being very new and very active in the industry. Every week is kind of changing. Maybe like whatever the answer I'm like about to give you might change in a week. So just like considering that fact. AI is not new, and but like the way the AI agents are like matured, just like recently has changed. And engineering is honestly is like not about like just like remembering the syntax and then like writing it like a code. I've been like coding for like last like 20 years. And when I started, I think just like remembering the syntax and doing a coding is a game changer. And also like, I mean, just like debugging any solution is also very highly like regarded skill. But now AI can do all those things really, really well. Um, Murphy law says if anything that can go wrong, that will that will go wrong. So engineering is not really a coding anymore. It is owning the outcome of the feature, and what is this like solutioning is all about. So as an engineer, we have to just like come out of the like a phase where you just like write a code and then you're like done with it. It is all about especially in like large scale system, and also like a payment system, when the real human involved and then real money involved, anything that can go wrong, that can end and like just like catastrophically wrong, starting from like financial losses, maybe just like losing like customer trust. And also there are like a lot of like just like regulations around the payment industry as well. So when you're like building a system, even if you're like taking a smallest of the feature, you have to think from like systematically. I can i can see that like all this like demo videos and then doing a vibe coding is all good, but when you're going into this like production system, all this like matter is like, how do you like define your system, and are you like just like systematically thinking your like feature, are you like taking care of this like redundancy, is your like API is idempotent. um, just like imagine, right? If you like allow one like duplicate transaction to just like come into a system, you are like charging them twice. And it's not a code problem, it is like how you like are just like thinking your system wise, right? Are you handling for the failover? Are you like gracefully like shutting down your system? Are you like just like taking care of all the guardrails and just like system failures? Like what happens, or like what situation you need to like care about the performance versus what situation you have to just like care about a code alone, right? So we all have to ask ourselves, can you design a system um, that can like survive all these like real trends? And especially in like Mastercard, we are like always like bound to be this like a like a government regulations, and then like PCA data, and then humans like personal money. And anything, even just like a milliseconds of like delay, we will lose like just like millions of transaction globally. So we cannot trust the AI to just like take over your seat. Being an engineer, you need to be on a front seat, where you use AI to help you implement faster. But as a engineer, you still own the outcome of it. Meaning, in like one line, are you taking accountability for the feature which you are like just like developing? That's a core of being an engineer. I think like that's not going to change however the AI is getting evolved.
That's really interesting, especially what you said about accountability and system thinking. Because when we are building any system in a real world infrastructure, what we really need to know is how the integration of different components is happening and how they're working all together as a system to make it function beautifully. And I think that's something everyone here who is watching this live or will be watching this stream in the future should pay attention to. Because what I can infer from your explanation is that coding is a commodity now, and anyone can code with AI, but only an intelligent person or an engineer who puts the code in context with his problem can successfully automate this business. And like coming to you, Srinjoy, what do you have to say on this?
Yeah, I'm more aligned like what Vijay told here. And also like coding was never the problem here. Like engineers, like if people believe that okay, like if you code, you are a software engineer, then that's the wrong idea you have perceived through your engineering days. Coding was never really the problem. Now AI can like do coding better. That's like my perception is that makes our life easier, not like scary that okay AI is gonna take our job or something. But uh, I more feel that okay AI can do the job, but as an engineer you should think the systems level thinking, the low level concepts you have to master fundamentally, so that you like think on a bigger scale. What happens when one service goes down? What happens that when a database fails? Or there are many thousands of scenarios that can happen in a distributed systems architecture, right? So that is really important in today's era, that not only coding, let's say in 2020 or 2019, if you uh, understood like 5 to 6 languages, like you are like pretty good, right? Like everybody assume like okay man, you know so much languages, that's pretty great. But today if you know 5 to 6 languages, like even those famous languages which are like getting trending right now, nobody is getting your value. Okay, you know so many languages, why we should hire you? So I guess in today's world, lots of companies are also looking in a multi-domain areas, like not only like, for example, if you're a front-end engineer or a back-end engineer or an AI engineer specifically, it will not work out that much, because in today's era, like AI can make a basic CRUD application or any like mediocre application in 2 to 3 hours, right? But in global scale or like an enterprise level application, will it handle all the edge cases there? Like as like Vijay was mentioning, every millisecond counts in a financial system, right? So there, all these things matter. Like for example, let's talk about like high frequency trading, right? That's like even like sub millisecond, if we lose there, that means thousands of like stock money goes down. So it really matters like where you can trust the AI to do your job and where you shouldn't. You can ask for suggestion. Like how I code in daily life is, I I mostly write like 30 or 20% of the code, 70 to 80% of the code AI writes, because like I obviously validate and see if everything is correct or not, and like go in an iterative manner to like finalize the code. But most of the like architectural decisions or the systematic decisions are made by me, and I also think from my perspective that's what most engineers do and should do also. That's what like gives you the power of controlling the your application on a lower level. In a lower level meaning you can like grasp your, you can make your operating system very powerful to the operating system. You can make your application so powerful in an operating system layer, so that nothing fails in your application. Even though it fails, it should handle nicely. So AI can't manage all these things. Even like from for me, I think great engineers are more needed in today's world. So that's my point of view of this thing. Yeah.
Yeah, I mean, thank you so much, Srinjoy, for this beautiful and lovely explanation. And it was a great insight into thinking, or let's say it was a strong reminder that models are only a small part of the equation. System thinking is what turns a demo into something that survive a real user in a real world infrastructure. And like what I am able to conclude, or let's say extract from Shinjoy and Vijay's point of view is that coding nowadays is not a big deal. What's harder is how to think in systems, how to make architectural decisions, and learning how to design for scale. And I guess that's where our platform, CodeMaster AI, comes in. It's not just about writing code in a browser, it's about building projects in a way that forces you to think about structure, trade offs, scalability, the stuff that actually matters once something goes live, that helps you create yourself as an industry ready engineer. And that mindset is exactly what powers our platform codemaster.ai. And Srinjoy, being the founding engineer of CodeMaster AI, I think no one could explain about the platform better than you. So, like, can you please explain about the platform to our users?
Yeah. So CodeMaster AI was built specifically for this type of cases where you don't need to be a very good programmer or a very good software engineer to always get a very your dream job. So for example, you are in your first year of college or your final year of college, or you have like a 5 to 6 years of experience. It doesn't matter who you are. You can always upskill yourselves. You can always improve yourselves, right? That is what Codemaster AI is for. It is for all the people out there to upskill, to be better as a software engineer and be that engineer that is demanding in your own company. So Codemaster AI has like couple of features which like enforces you and empowers you to become a greater engineer day by day. It like focuses on your core principles. It you can like go and practice mock interviews which are AI powered interviews, and nowadays a lot of interviews are AI powered also. So lot of people doesn't have that experience talking to an AI during that interview. So
Correct.
all these things are really important, where our mock interview features signs out pretty nicely. You can practice mock interviews. You can practice mock interviews, and you can build project challenges. All these things are pretty nice to practice in day to day life. For example, we have like a coding interview platform
Right.
where in the coding interview platform you can go in and literally an AI can you can share your screen writing your code, and the AI can see your code and ask you what is this edge case, how will you handle it, what is the time complexity, all these things, how exactly a coding interview happens in day to day life, right? So that is what our platform exactly duplicates, so that you are like prepared for all those pressure cooker moments on the real life scenario. So you are prepared for from the uh, top to bottom, so you can like crack your dream job or upskill yourselves on your current job, doesn't matter where you are.
I absolutely agree, and I think this is where the things get legit interesting, where we practice about coding challenges and give AI powered mock interviews, because most students nowadays what they do is they just focus on DSA. Some focus on purely on DSA and some just focus on frameworks, but very few focus on how components talk to each other, how the integration is happening between the different modules of the system. Like they don't know, or let's say a very few or a handful of engineers nowadays understand how traffic flows, how to handle the trade-offs, how failures are handled. And I guess that's what separates feature builders from thinkers. And this is where our platform Codemaster AI comes into light, because it helps you become an impactful engineer that every company needs, right, Srinjoy?
Yeah, yeah, absolutely right.
Exactly. And yeah, Vijay, you want to add something?
I would just say, I mean, like the platform sounds interesting. Like, do you wanna share a screen and then show the features a little bit?
Yeah, Srinjoy, can you
Yeah,
please?
yeah, for sure. So let me share my screen. Yeah, is my screen visible?
Yeah, it's visible.
Okay. Yeah. So this is our application, Codemaster AI, where you can basically our motto is learn, build, practice, get hired. So you can learn stuff, you can build whatever you want, build all the trending core fundamental challenges you face in like enterprise scale. And after you have done that, you can practice it daily and upskill yourself, and at the end of the day you can like if you reach that level of perfection, obviously you will get hired. So This is our like application, and we have a couple of features. Like for
Mm.
example, if we go to the mock interview feature, which I was talking about, like where you can
Mm.
practice uh, skill based interviews, coding interviews, and even soft skill interviews. Like
And
for
we can
example,
also
you have an
build
interview.
custom interviews also, like on demand interviews. The unique
Yeah,
feature about our platform
yeah, yeah, right.
KodeMaster AI is that suppose next day you have an interview at a company, let's say Oracle, and the job description of the company or of the role is given, and now you're hell scared as in how to prepare for the interview, or you are thinking that wish there was a mock interview legit aligned with the JD. So the key feature of our platform is that you can create on demand interviews based on the job description of the role of the company you are aspiring for. So, along with the job based, role based, skill based, and soft skill interview, we also have this custom interview option also on our platform. Yeah, Srinjoy.
Yeah, right. So, for example, as like Divya was mentioning, right? For
Mm.
example, you are having your campus placements going on, and
Mm.
you have your campus drive for your dream placement, dream company, and you wish that you can like practice the entire round in your home. So, let's say the company has one technical round, one coding round, and at the end the HR round. So you can just hop into Codemaster AI and you can like basically practice all of these interviews before actually giving the actual interview. So if you go to skill based interview, you can like practice all the technical interviews for your designated role. For example, you are trying to get hired as a backend developer, you can focus on backend developing interviews where the AI will ask you all the real life questions that gets actually asked in most of the backend interviews, and you can get familiar with all these type of questions so that you don't fumble in that actual interview. Same goes to the coding interview. As I mentioned earlier, that this coding interview, the AI behaves exactly as how a coding interviewer behaves. Like it, when you share your screen and you code, you don't actually code there. You have to explain your thought process. You have to code. You have to show your problem solving thing skills there. The interviewer will ask you a lot of questions like, what are the edge cases you are handling? What if this is different? What if that is different? The interviewer will tweak a little bit of your question and ask you, and all these things, like all these like heated moments which you like face for your first time in an actual interview, you can, most of the people are not that much experienced or that much prepared. Like after 10 to 12 interviews, they get the confidence, okay, now I can go and give an interview. But before that, if you can have an experience that okay, this is what it feels like to have give a coding interview or a technical interview, then you get much more confidence that okay, I'm ready for this situation, and
Mm.
you can ace it. So that is why, like in cricket also, right? In cricket or football, like players do net practice and then uh, play the actual match. So this is the net practice for software engineering. You can like do your net practice here, and when the real match comes, you can just you are all ready to go, and you can just give out your best. Same goes
Yeah.
for the soft skill interview. It is like the final interview where HR asks you all these questions and you have to answer based on your experience and your thinking. So Codemaster AI also prepares you for that, where you can handle all this like tricky HR questions, which like often people after clearing multiple rounds, like technical coding interviews, in a HR round, people get rejected. So some tricky questions are there which are really important to know. All these things are like covered in Codemaster AI, which helps you prepare for your job. And as Divya mentioned, uh, people can create their own interview. For example, if you have a job description and you want to prepare for that particular job description, then you can basically paste your job description here, and our AI will create that particular interview environment for you. And for job description, if you want to do a technical interview, a coding interview, or a soft skill interview, it completely depends upon you. So you can just do your net practice right out there. So that's for the mock interview feature of Codemaster AI. We have some couple of other features as well, where it's like there is like coding challenges. Like for coding, like there are a lot of in this coding interviews, there are a lot of like fundamental questions that are asked regarding data structures and algorithms and low level coding, right? So lot of questions are there out there in some other platforms, but the main thing that Codemaster AI's coding challenges focuses on are that some good questions, some unique questions, and which are actually like tests you on your actual coding interview. In in companies, interviewer doesn't ask you a very familiar question. Sometimes you get lucky that okay, this question is like almost similar, but sometimes what happens is the question is a little bit tweaked. The question is completely different. The question is of a new concept. So Codemaster AI has this unique set of coding challenges where you can like practice your coding skills, like your data structure algorithm skills, in a daily basis, and it gets you prepared for your coding interview. And coming up to the most interesting feature of our application, the project challenges. So as we were speaking, right, as Vijay told, as me told, and Divya mentioned, so coding in this AI era is not that important. It is still important, but not that important. But that system level thinking is what matters in today's life. So this is what our application, this project challenge feature basically focuses on. For example, we have like couple of challenges like build your own Unix shell, like your day-to-day terminal, how you like talk to your terminal daily, you're traveling through file paths, all these things you are doing in your daily day-to-day life, building applications. So what if you can make your own Unix shell, build your own garbage collectors, all these programming languages, Java, Golang, C++, their how does their garbage collector operates? And new programming languages like Rust, they don't have a garbage collector only. So why does that language doesn't have a garbage collector? And what is the use of garbage collector? So all these theoretical concepts you may know, but have you tried building your own garbage collector? That how does garbage collection operates in that scale? So all these uh, challenges to try to build your that part of the brain which is like involves all this systematic thinking. Like you can go really core low level and think of this kind of scenarios where all the edge cases and all the tolerance behaviors you can tackle and get ready for the real world. So as speaking, there is like build your own Python interpreter, make your own Python compiler. Like you can make your own compiler at the end of the day, and build your own load balancer that is like that powers like every other applications. You're talking to ChatGPT the entire day. 800 million people does at the same time you are doing. So if you send 800 million requests to a server, the server will die, right? So everything load balancer runs the entire internet. So if you are trying to build your own load balancer, that will be very amazing, right? So why don't you try to build your own load balancer? So asking you, Vijay, as much of experience you have, um, what do you think like this kind of projects or all these things, like this kind of whole level projects is at these projects in the resume? Uh, how will a recruiter or a senior engineer feel?
Vijay, you are on mute.
Yeah, yeah. I mean, like this is just like I mean, just like looking like really great. And a- as like recruiter in my team, I always go to like I mean, they're like LinkedIn and then just like GitHub uh, portfolio or like whatever the projects they will be like just like building. And this like project building challenges like seems to be really good where they get to have this like real world experience. That's amazing. I guess like to like see it in life. Or
Yeah.
to Divya.
Yeah, I mean, I agree with Vijay's point of view as well. And I see that these are not just simple demo projects, these are real world projects. And I guess these are the projects which any uh, aspiring engineer can include in their resume to make their resume a differentiator from a pile of resumes which are aspiring for the same role. And I think here we have AI assisted code, AI assistant also, which helps us in building the project. So I think that's a very unique key feature about the platform, because what usually happens is we just chat GPT our problem, and the chat GPT just provides us the solution to that problem. We are not forced to think about how to debug that problem in a low level thinking, like how to solve that problem at a very basic level. At ChatGPT, we just simply get the solution, so we don't use much of our brain. But with the AI assistants over here, the AI or the chatbot of their platform doesn't give the solution at the very go. It forces you to scratch your head and think about why the hell this problem is occurring and how you can solve this problem independently. And I guess that's the very unique feature about the platform. And I'm really looking forward to exploring this. But Srinjoy, I see there is this events tab also in the homepage. Can you please
Yeah,
show that?
absolutely. Yeah,
See, and see, for all this while we have been talking about building real systems. System thinking is what separates a demo project from a real world projects, and that is the same philosophy what that which led to the building of Build with Codemaster AI hackathon powered by Genesis. This is not just another competition, because this is a startup energy corporate style hackathon, because some competitions might give you recognition, some might give you rewards, but a rare few open real doors, and that's exactly what this hackathon is designed to do. You are judged on the clarity of your thought, the execution, the scalability, and the long term vision, because real world systems are not built overnight. And yes, I mean, the stakes are real. If you participate in this hackathon and score a good position, there will be an investment opportunity up to rupees 25 lakhs, cash prizes up to rupees 1 lakh, paid internship opportunity at Codemaster AI, and direct evaluation by seasoned industry leaders. And obviously, exclusive sessions from professionals like people from Mastercards, Microsoft, and other leading organizations. So, guys, if you haven't registered for the hackathon yet, go to the platform and hit the register button and participate with your team and make the month of March count impactfully in your professional career. So, over to you, Shinjoy. What do you have to say about this hackathon? Like, how can you motivate these participants to participate in this hackathon?
yeah. I mean, like, it's a great place to show out your ideas, I guess.
Hmm.
Like, let's say I have, like, every day I get some ideas about this Codemaster AI, what new features to add, how can new learners get some more great experience and get their dream job. So all these ideas is like for new people or any people, this platform is the place where you can show out your ideas, like how good of a thinker you are, how much you can build nicely with your team. So I guess it's a great place to show out your enthusiasm about software engineering. And yeah.
Yeah, I mean, I totally agree with you, because hackathons are an event which forces you to build under pressure and build so beautifully that you are able to create a production ready system within a span of 4 to 5 days, and with obviously with the help of teamwork. Because no matter where you are, no matter what you are, or in whatever organization you are in, teamwork is something which you should be knowing, and handling or building under pressure is something what will make you irreplaceable in any organization at any place you're going to work in. So people watching this, go to the platform and register for the hackathon. Well, we all have been talking about building load balancer and all. So Shinjoy, can we now start with the main agenda for what we have joined this webinar? Exploring the project build feature of Codemaster AI and building a load balancer from scratch under your guidance, so with your explanation.
Yeah, sure. So as we have been all saying, like build your own load balancer, build your own garbage collector. Let's actually try out what is needed to actually build your own load balancer. So let's see.
But Srinjoy, one thing, like before we
Yep.
start building this, I just now that we know what we are building a balancer. Let's understand uh, what we are building. As in,
Mhm.
before writing a single line of code, we need clarity on architecture.
Mhm.
Vijay, considering your expertise in this, could you please help us understand the architecture behind a load balancer? What problem does it solve, and why do we need it? And how is it implemented in a real world distributed systems like the ones you have worked at Mastercards?
Yeah, sure. Hopefully you can hear me. So like this is where like in the large scale organization, each system you just like just like put into your system plays a key role. You have to like decide between various options available. Even with the load balancer, we have an option of just like going with like simple load balancer, or doing like reverse proxy, or do you want to go with the API gateway and other stuff, right? Even the load balancer itself, there are like various options from a different company, different provider itself. And like hopefully like all the people who are like participating like knows about this like BOSI model. There are like various layer where the users start from the connection all the way to like going to a server and then like getting the response back. There are like layer 4 load balancer and layer 7 load balancer. I would like to share my screen and then maybe walk you guys through some kind of understanding like where this like load balancer is like coming from. Give me a second.
Sure.
All right. Hopefully you can see my screen.
Yeah, Vijay.
Right. So we all know that like you can use AI agents to like wipe code any application. Let's say you have an app here, which is your backend system. You have a just like server here, and the user can be from anywhere in the world. And just like before going here, like this is your system where you are just like doing just like connecting your server during this like development uh, cycle. uh, that will work good, but when you want to expose your like server to the outside world, then you need to establish this like internet connection and then exposing your service outside, right? You can directly expose your like services using so many options now, so where the user will just like directly just like connect to your server and then get the response. What happens if your idea started growing and then just like so many people are just like coming into the picture? And when you are like designing an app, that's where those like system thinking comes into into your mama mind, right? Where how do you make sure your like systems are safe from so many just like security hurdles, from like DDoS attack to people trying to like reach your server? And how do you control your authentication? Like how do you control who get to access, and what is about this like rate limiting, like how do you kind of like distribute the load, all those things into just like picture, right? So you never want to expose your server like directly to the user. That's where you can attach this like reverse proxy. uh, Sorry about that. Yeah. So this like reverse proxy is a like system you just like put in between of your user and a server, where you want to mask what is behind the like grandiose your wall, and then give only or like expose only just like reverse proxy to the user. And once you give it, where you have like a lot, I mean just like a lot of control, like how do you want to handle the traffic itself. You can like watch for like all kind of attacks and all kind of access and just like controls before you are just like hitting your like server, right? um, so you have like one server, so you just like put your user and then directly to this like reverse proxy, and then your like server get to handle. What if your app is like really famous, and then maybe just like millions of users are like coming. That's where this like distributed kind of system, or like how do you scale your server. You can obviously just like put more capacity to the server and then scale your server vertically. Instead of like small server, you can just like put more, but there is always just like limit to how much you can scale your server, right? That's where you can do like horizontal scaling. Instead of like server one, you can add another server of the same like a same server, but you're just like, I mean, you're just like creating another instance of it, and you do like server three. So this like reverse proxy is just like a forwarding your like request. It doesn't handle like really like based on your traffic, like where to like route your server, right? Then like forwarding the traffic plus like deciding where your like user request goes into the service is what that like algorithm you can just like put in. And then this like combined can decide, okay, so there are just like millions of users are like coming in, and now you, I mean, there are like three servers here, and how do you I mean, uh, how do you like route your traffic. uh, that's where this load balancer concept, just uh, like a basic of load balancer just like comes into a picture. And load balancer itself has like a lot of component to handle your like health check, um, like just like deciding if your like server is active, and you can even just like control based on different configurations of the like server itself. I will like just like quickly show you. I mean, I just like drawn out this like overall low level architecture you can see here. Um, Basically like the same thing. I mean, your user record just like comes in. You can just like put this at the OSI level at the layer 4 or the layer 7. So the layer 4 doesn't understand all this URL pattern and then just like cookies and header, all those things, right? It just like sees your IP address. It's like more of like a postman, where it just like sees your address and then just like send your letter to your home. It doesn't know like what is this like, I mean, just like context about, or in the home like where it has like route to, all those things it doesn't understand. So it's just like a very like TCP layer at the layer 4 of the network. It just like sees your just like request IP and port, and then like route this like service like directly to your uh, backend. And these days, I think these like industries are like using a combination of like layer 4 and like layer 7, and they just do with um, app layer. Basically, this like layer 7 load balancer can see your like URL path and like header cookies and all sort of information. It goes through a various step, and then this like component itself involves like a lot of like I mean logic or like feature it has to kind of handle, and then it like routes your traffic to a various backend. um, so the main motive or like the main reason why we put load balancer is like efficiently like route a traffic, and then not like bombard your server with like just like millions of just like request. And before, I mean, I hope like the codemaster, this build your own the load balancer kind of handles all these things. uh, with this, like, I mean, maybe like Srinjoy can like explain just like a little bit about how he thinks about it.
Yeah. So yeah, exactly. For like this project challenge, build your own load balancer. All these things are taken into place where load balancers, all these features shine. For example, if we take, um, first of all, before going into what is load balancer, what are their features, we can like say how did load balancers came into, like before. Let's say if you are, let's say for one time, if we just think, okay, there is no load balancer, how does things operate? So then the thing that comes in place is, for example, you, me, everyone talks to chat gpt, right, or any other applications. So chat gpt like recently pulled out a blog that they have like 800 million users using every single minute, right? So you are sending a chat to ChatGPT, like, okay, give me something about this, right? And that request goes to ChatGPT server. So now 800 million users, let's say in 1 minute 800 million, let's say 1 million users, right? 1 million users are chatting in the exact same minute. At t equals to 0 seconds, 1 million users are sending you request concurrently to that single server. Then what would happen? It would collapse, right? It would break down. So here now engineers and scientists will think, okay, how do we do this? Then do you think that okay, from one server we can like scale up five different servers, like same code running in five different servers, and if we like push the traffic to one server and that server says, okay, I'm overwhelmed, go to my friend, that is another server that will handle your request. Will that be the optimal case? That works, that okay, if one server is overloaded, it can route traffic to another server and then another server and then another server. But that is very inefficient there, right? So what engineers and scientists thought about is building something which can balance load between multiple instances of a server. So ChatGPT is like first API layer. The primary backend service has like multiple instances of it. Let's say, for example, they are running 10 instances of it, which handles load concurrently and all those things. So how does this load balancer or some service, let's not call it load balancer for now, how does this service spread out to these all different instances, like very like in a programmatic way? For example, if you are going into a restaurant, right, and there are four chefs, and everybody is rushing into that restaurant, so everybody will go to one chef or two chef, or will not know, okay, which chef is like more free or which chef has more number of orders to cook. So you will not know and go to one chef and give your order, but you never know that chef is overwhelmed or not. So your food will come late, right? So the same analogy is that in terms of applications, if a server is overwhelmed, your request will take time to get processed. So with the same analogy, how does a how does a load balancer come in this like real life scenario? You will add a host, right? The host will route those users to different chefs. The host will ask, okay, like chef one, are you free? So chef one tells, okay, I have like three orders, but I am free than the others. So that request the host, that user goes to the chef three there. So you see, the host is doing the load balancer's job here in a simple manner. So in the real world also, in very simple layman terms, load balancer does the same thing, that it routes traffic to different instances of a single backend server, so that the application handles each and every request in a very nice way. So that is like that was like a very brief about load balancers, and like all these like features like Vijay explained. I would like to like show like how, or I would like to explain like all these features in a like a okay manner when we build these features. Like our build your own load balancer consists of all these features which load balancer contains, like the reverse proxy model, like the code mental model, like how the load balancers acts as a reverse proxy model. Then the backend pool, like what do I mean by backend pool is the load balancers, how many servers it is handling, right? If you have like 10 servers which the load balancer is serving, so that is the backend pool state the load balancer is handling, that okay, like backend one is having this much weightage, it is healthy, true or false, and it has stats as okay, it last handled 500 concurrent requests, so and so. So that is the backend pool and state of a load balancer. Then comes like different routing algorithms in a load balancer. Like there is like random algorithm, there is round robin algorithm, there is weighted round robin algorithm. How does those algorithms takes in place while like routing requests to different backend services? Then, like as Vijay mentioned, there is health checks. Like don't send dead traffic to dead servers, right? How will you like if a chef is not cooking and if a user is asking food, they will not get their food, right? The user will get unsatisfied. Same comes here also. Like the load balancer or the host of the restaurant has to ask the chef, "Are you okay? Are you okay?" If the chef tells, "Okay, I'm okay," then it's fine. It can handle the next customer. And how load balancer handles like this kind of health checks, like passive health checks, full health checks, all these things, how it handles timeouts and retries. Let's say if you send a request, the backend instance um, doesn't process that request, it doesn't send any response. How will the load balancer treat it? The load balancer will treat it as a failed request. Then how does it retry? If it retries, does it like bombard with retries or does it retries in a sequential manner? All these things are like the features of load balancers, which are like the covered in the project challenge of Codemaster AI Build Your Own Load Balancer, which we will work through some basic steps and like yeah.
Yeah, I mean, that was a really insightful explanation. Thank you, Srinjoy and Vijay, for the great insight. And since now that we know what load balancer exactly is, and now we know about the architecture of the load balancer, I think now it's the right time that now we start implementing the load balancer from scratch with the help of the project build feature of Codemaster AI. So over to you, Srinjoy.
Yeah, sure. I'm gonna share my screen here. Yeah. Okay. Yeah. As we discussed what is load balancer, so here it's the same thing written in a like a textual manner. What we are going to build, what are load balancers? As you can see, it is mentioning load balancers are the unsung heroes, which is like very true. It runs the entire internet. And like the tech stack we are gonna pick here is the language we are picking TypeScript, but this project challenge will support multiple languages for this particular challenge. But if you think in a big scale, load balancers and this type of low level services should be like where it involves this kind of like network level concurrency. Most favorable language is Golang with the package manager Jin, but we are exploring TypeScript here with the Bun runtime. If you have heard about Bun runtime, Bun is like very blazing fast, like closer to Golang's performance. So it is getting like more trending day by day using TypeScript and Bun. And the architecture, like as
So
Vijay,
you want to zoom your screen a little bit?
yeah, yeah, sure. Is it fine now? Or
Yeah.
okay.
Yeah,
So
it's good.
yeah. The architecture we discussed what is the architecture of load balancers are, and like while building this particular project challenge we will like get an idea of how like load balancers operate, how you get that mental model of like processing different backend instances and routing traffic with different algorithms and at that level of scale. So the journey will be of 20 steps. Like the first phase will be like setting up the basic project structure, setting up some like boilerplate code, like robust configuration management, core objects that represent your backend servers. And the second phase will be the code logic. We will implement like different algorithms that power the load balancer, the random algorithm, the round robin algorithm, the weighted round robin algorithm. How does those algorithms help to route traffic to different backend instances? And the third phase is the resilience. The resilience of load balancer is very important, like this health check patterns, the passive health check patterns, the retry logic, how does it do the retry logic and all those things. And advanced features comes at the phase 4, that is step 16 to 20. That is the self-healing capabilities, the real-time stats monitoring, and the dynamic configuration updates. So like the phase 4 consists of all the recent features that are like recently introduced into like modern day load balancer with like real time stats monitoring, and you can check your backend health status or your uh, pool of backend servers, how they are processing requests, how much time they are taking to process requests, everything in a good dashboard kind of way. So yeah, before we start, do we have any questions to discuss or anything?
Yeah, like hopefully the project covers like just like taking a traffic and then just like doing this like real time, like having the server and like not like just like tutorial kind, right? I
Yeah.
mean like do you get like just like build your like actual system and like just like test it out?
Yeah, yeah. So right now, what I will show you is like it's a, like a very interesting way to like build out the entire project. It's a, like a validating way of like each step you build something with a guided manner and you validate your step that it actually worked or not. And uh, yeah, like for the load balancer, we are covering all the steps. Like you are building the actual load balancer. At the end of the day, you can Dockerize this particular application and you can deploy. And whatever application you have, uh, backend pool, you can use your own load balancer rather than using AWS. Like obviously, AWS will be the better one for now, but why not try out? So
Yeah.
let's.
I would like to just like maybe ask like a few clarifying questions to the audience as well,
Mhm,
or just like share like few like facts as well, like just like before you start, right?
mhm,
um as I said, kind of just like reverse proxy, load balancer, and then the API gateway kind of overlaps in terms of the feature and then what it can do
mhm,
and how it like serves the traffic.
mhm,
But architecturally, I mean, in this like enterprise, if like all are doing the same thing, then why do we have this like different feature or like just like different tools and like different stuff, right? So how do you position your piece into the overall puzzle is what is going to be just like differentiating these things, right? The
mhm,
load balancer, the main core principle is how do you like distribute the traffic. But this like reverse proxy is just like all it care about is like forwarding your traffic and just like controlling the traffic, like in terms of the
mhm.
auth, in terms of this like rate limiting, and
Right.
just like stuff like that, right?
Mm,
And uh, you can think that okay, so in the load balancer you can do auth and then just like rate limiting and then the API versioning, all those things. Like say if you're exposing your API as a product, you can just like simply put a load balancer and then just like control the user in terms of like versioning and stuff like that. But you cannot do that with a load balancer or just like reverse proxy itself. So that's where the API gateway comes into the picture. So the API
mm,
gateway is overall idea of things is like a governing, and then how do you enforce your policies, right? You can add your like rate limiting there, you can version your API, and even you can charge for your API, all those things. um, so if we are transferring a load from the user in a like different way, one key difference from a API gateway to a load balancer is the load balancer is like just like supposed to be just like distributing the traffic to the same server, meaning you will get like instance of your same server just horizontally scaled, and you just like route your traffic from one instance to the other instance to not to overburden your backend. But the API gateway job is it kind of understand the just like traffic path or like just like traffic just like route. It can route to a different services as well. So you might be having the ordering service, or you might be ha- having maybe like a user export service. So the API gateway can see your path and just like route it to like just like different server. Rather, load balancer job is there is only one service. You just like you horizontally scaled it, and then you're just like routing a traffic. So yeah, yeah, like we can just get started, and then you could share like how you are like how your like first step is, and if you want to explain about maybe the IDE feature and stuff like that, and then we can get started.
Yeah, sure. So before starting, I would like to show you like basically this project you can build, like for example you are coding this entire project, right? And while coding your project you can connect with GitHub with CodeMaster AI, and you can basically mirror your entire project while like coding here to GitHub. So while coding, the project's clone will be mirrored to your GitHub also. So that is like really important, like to showcase this kind of like core low level projects into your resumes, like GitHub and other platforms. And obviously, like I will start the challenge now. Like, let's start. Yeah. So I got a git clone URL. Let me open my terminal. And let me copy this command. Okay, and I'm opening my VS Code right now, and let me share you my VS Code screen. I think it is not visible. Give me a second.
Does each user get their own like repository for them to I mean like go from the steps?
Yeah, right, exactly. So each user gets their own repository, which is people can get confused. This is like GitHub repository, but it is not exactly a GitHub repository. Um, it is like, for example, a repository which is self-hosted on CodeMaster AI's platform, but you can code there and push your step, whatever progress you have made, and CodeMaster AI validates each and every step while you progress through the entire challenge. So that's way how it identifies whether you are building it right or you are making some mistakes.
Oh,
Okay, okay, let me share the screen, please. One second, I think screen share is not working. Mm-hmm.
In the meanwhile, like Srinjoy will be sharing the screen. Vijay, I had one question to ask you. Like, it may sound very layman, but I just had this really curious question to ask to you. What's the difference between horizontal scaling and vertical scaling in practical terms? Like, if you could share your
right.
insights on this.
Yeah, sure. So when we are like deploying any backend services, generally we just like Dockerize it and then deploy the services with like say for example like a 4 gig and then like a 4 gig RAM and 8 gig um, just um, just like space, and then I mean like there comes like a CPU and there comes like memory. You can just like define how much core you want, all those things, right? So you usually like deploy your services, and when you deployed it based on a traffic, you can increase your CPU and like memory from 4 CPU to you can go to all the way to like 64 and then just like 94. Also like some of like a beefier system you can just like have just like 94 CPU and then just like terabytes of like RAM, right? um, but there is like limit to how much you can scale vertically. So basically you like take a base version of your server and then keep putting more and more uh, I mean, just like power to your server. What that really do is you get like a single system to manage, but failure do happen, right? If like that server get crashed, then your whole system got like crashed, and then your like users will not be able to serve. So it is always architecturally advised to scale horizontally, meaning you copy the same instance from a 4 CPU 8 gig core, and then just like multiply that. Cost wise, it's going to be same, but there's going to be like a management to it. But this will really give you kind of high availability, and you can patch it really just like systematically. You can like patch off of your services with like new version, and other off can be done. So this will kind of create like very high availability, like low downtime during a deployment, during a crash, or during attack. You can always just like scale down, scale up, and when the load increases, then all the cloud services will give you option to scale out horizontally so easy, like where you can just like spin up like just like hundreds of server, and your load balancer will like take care of like routing a traffic from one service to the other based on the load. So in like one line, if you put like put a more power to the same service and then keep increasing the capacity of a service, that's like a vertical scaling. And you keep your like minimal services or like server backend, and then kind of duplicate that services more, and then just like router traffic. That's the horizontal scaling.
Wow, I mean, that was a wonderful explanation. And that legit cleared my confusion towards when to go for horizontal or when to go for vertical scaling. So, thank you so much for that. And I see that now Srinjoy is able to share his screen. So, over to you, Srinjoy, now.
Yeah. So finally, I can share my screen, and yeah, let's start. So before starting, instead of switching tabs, also like we have a Chrome extension for which you can view your current um, project challenges content directly in your VS Code rather than switching tabs here and there. So everything at one place, and you can like build out your entire project challenge without leaving your VS Code itself. So let's start. And I have cloned my project, and as you can see, this is like a template file I get, that is index.ts file, which is empty right now, a git ignore, a package.json, and tsconfig. So everything is a template file. And the first step is telling me to, okay, I've cloned it, I will do a git commit. Let's do the git commit here. Mhm. Okay. Git commit, and let's set the branch, and let's push the code. I guess the next command is git push origin main. So this first initial step is to just to verify everything that you are connected and you are ready to go. So yeah, sounds good. Let's sync our status, and yeah, you are on to the first step. So the first step is project setup. So let's see what does the project mission says here. A robust distributed system needs a solid foundation. TypeScript project using Burn and modern JavaScript. Okay, why Burn? Okay, got it. Okay, so the first step is basically we have to install our packages and like set up our TS config or TypeScript configuration and see our like everything is ready to go. Just before you drive, you just check you have what your seat belt or not, that kind of thing. So let's run burn install command, which is the content is suggesting us to. Let's copy this and simply run it. Okay, and let's go, and okay, we have to check our TypeScript configuration. Let's check our TypeScript configuration. Um, check out that. Yeah. So everything looks pretty much the same. And okay, in index.ts, we have to add our basic routing structure there. That is, if you see like before, this is a basically load balancer is also a service. So
Right.
before writing our actual load balancer logic here, we will like implement a basic like starting route for our load balancer. So as it is giving the entire template, that is basic template, we'll just exactly copy this out and paste it here. It is like it is importing express from the express library. It is like making the application as the express runtime, sorry, the express HTTP layer, and port is 7010 for now. You will see why this changes later, and this is the first route, so it will just say you, okay, load balancer is in version 1.0, and the application listens on the port 7010. So that is there. Let's verify by running this command. Okay, load balancer running on port 7010. That's good. Um, let's go, and yeah, our save point is we have to push our code to make sure the step gets validated. So let's push our code. Okay, that's nice. Codemaster AI's platform validates that your particular step got actually right or wrong. So as you can see, all tests got passed. So we are good to move on to the next step. Okay. Yeah. The step two is basically making robust configuration. Like, for example, like um, if we, for example, in a distributed system, right? In a distributed system, issue hard code values. Do you think it will be really reliable? Like in a distributed system, data flows in many directions, right? If you have hard coded values, it will be a sin. So, as it is saying, hard coding values is a sin in distributed systems. A load balancer needs to be configurable without changing code. We need to define which port to listen on, which algorithms to use, where are the backend servers. So, the main gist of this step is like now we are going to separate the code from the configuration, which is how like real systems are operated. This step then generally demands like we have to put the load balancer settings in config.json. Like as it is saying, we have to create a config file and a config.json file where we will define what are the backend instances the load balancer is serving to. For example, if someone has experience on like deploying, like making their load balancers serve for their backend instances in AWS or GCP or Azure, they might have seen like for their backend instances, they have to do some configuration for it. So this is the exact configuration. Sorry for that. This is the exact configuration they need to make so that the load balancer knows that okay, this is the backend I'm serving routing traffic to. So this is the configuration file we have to make, and this config, the main point of making this config driven behavior and contract validation, because in deployment mistakes will get caught early, so that if some configuration is wrong or something, it will get caught early, other than load balancer routing traffic to a different or wrong backend, right? So from here onward, we can change behavior by config, not by rewriting code every time. So let's say you change the port or change the weightage of some backend instance, you can just change from the config. That is why you should like have a modular structure, and that is the point of this config.json here. Okay. Um, After explaining the config.json, let's like create the config.json right now. Touch config.json, and the file is created. Let's open config.json, not ps. Yeah, config.json, and I will just copy the entire configuration, which is like a demo configuration for now. We will just create our in the later steps. We create our this kind of like small demo backends, like running on port 8081 and 8082, and we test it out on local and also on the validating layer also, that when you run your 8081 and 8082 backend instances on those ports, the load balancer routes traffic to those different backends. So for now, we will just hard code it, and later we will make those like sample demo backends. And now it is telling us to create the config class. So let's see what it tells us to do. You need to implement a class that loads this file and validates it. We have to have an interface. We have to define an interface config. Okay, that matches our JSON structure. So this is the config.json, right? We have to match this JSON structure, and we are using JOI Joey here. Joey is like, if you guys have used Zod, which is a famous like structure validating library. Joey is also the same thing, but Joey is like more popular among backend systems to use. So that's why we are using it here. And this is the validation we are gonna do. Okay, so I will just go and like start implementing the class here. That is the config class. So I'll start with making the file first. While I make the file, if anybody has any questions, please feel free to ask.
I mean, I can just like really see that. I mean, you're not like building a tie, like how you are like managing this like configuration, and then how the platform suggests you to use all this like variables, like instead of hard coding into your code, and it is like suggesting you to like create a configuration, and hope like if like people just like remember this like 12 factor application, creating any sort of like services. I mean, just like one of the principle on those like 12 factor application which I generally use like wherever there is a coding or like there is a this like system designing. One of the important factor is like do not put your values hard coded into your app, and any changes you are like redeploy, and then it like always like keep, I mean, just like keep like things very messy. So keeping a configuration is like a really just like good way of like putting it. And I see that in your platform, in your code, when you're doing a code and then you're able to like push it, and then like hopefully it's like doing like real validation, and then if like doing
Yeah,
something wrong, and then queues you like validated response, it's just like right in there. That's, I mean, amazing to see here.
yeah. So let's see if it validates for real right now. I've just not implemented anything. Let's see. Let's do git status. It is not complete step two, but I'm just gonna push it and let's see something. Okay, the step failed because it's incomplete, right? So we have to do each and every step correctly in order to complete the entire challenge. So this is like, let's say you are building a load balancer. Let's say you find out any content in the internet where you can build your own load balancer. But how do you know you are building it the right way? How do you know you are building the entire perfect load balancer or not? You can always ask AI that whether I have built it perfectly or not. But if you use AI for a long time, you know that AI is made for user satisfaction. So even if you made load balancer, but it is not that production grade or not that good fundamentally, it will still say it is fine. But people need to learn things the right way. That is what CodeMaster AI is doing. That you are making the entire project in a self-validating manner by validating each step and moving each step and building the project end to end in a modular structural manner.
Yeah,
Okay.
that's I mean, just like right way to just like put it. And like while you're coding, maybe I'll just like share like some of the thoughts. Um, so uh, in this like software industry, like people started going from this like waterfall approach to the agile, and then going all the way these days like yeah coding. But there are like few things like doesn't change, or like there's like it's like more important now for the in this like AI era. One thing which like people use is this like test driven development. I feel like we are following the same thing where you just like write, I mean, usually get all your like requirement and then create all the test before you even start your coding, and then you like define your test and then start coding and then validate against your spec to make sure you're not uh, implementing something not intended, and then also like satisfying all those like, I mean, all those like use cases. So by practicing this in a way, you are really getting ready for the enterprise grade.
Yep. Okay. So as I'm making the class here, so first what I'm doing is, so as I mentioned in the documentation, we have to like make the config class here, which basically validates like the config and everything is fine or not. So when you are declaring your backend, so in future steps we will also make our backend server details class. So for example, your load balancer service is routing traffic to different backend, right? How does it know the backend structure and everything? So this is like the modular monolithical structure we are following. That is, you will make a class of it, and when you are using it, you will make an object instance of it, and you will use that in that manner. So whatever the config of that particular backend is, it doesn't matter. So that's why we are making a class of it. So whatever backend configuration it is, it supports that. So this is the interface of the backend server config we just made. That is the domain of the backend, and the weight does it what is it hold. Don't worry about the weight for now. The weight is for future when we use different kind of routing algorithms like round robin, weighted round robin. Weighted round robin uses this kind of weights which comes into that picture. So now I'm making the full application config. That is, uh, so yeah. So let's go with the LB port. So the load balancer port is just the number type, which is the listening port for that particular backend. And LB algo is the algorithm which the load balancer currently holds. Let's see what is the exact type here. Okay, it's LB algo like this. Let's just copy it, something like this. And algo is like supports different, right? So it's gonna be random algorithm. Let's do it like this. Later we can like define enums for it, but this is also fine. WRR, this is weighted round robin, and backend servers is gonna be this thing, right? This is the backend server config. So we are gonna say I backend server config here. Sounds good. And this is how we define it. And now we have defined the interfaces here, as you can see. Now this comes the singleton pattern of it. So we have to make the config class. We have to define the constructor there. Okay, and we have to validate using joy schema. Fine. So let's export the class.
Okay. I mean, while you're coding, I can share like some of those algorithm pattern, why we are
Mhm.
using this like round robin and then this like
Mhm.
weighted round robin.
Yeah.
So we all know that from this like load balancer, we have to just like route your traffic to your like different backend system, right? So this is like a programmatically designed to kind of see where your traffic can go, and underlying, say you have like a 3 or 4 services or 3 or 4 backend system there, and how do you efficiently transfer your like traffic out there to like just like backend, right? You can just like randomly do it, and I mean that is also like a valid pattern, by the way. So you can just like choose a random, and if your backend system is all same, it can just like randomly choose. And there is this like round robin. So this like round robin is an algorithm where it just goes one after the other, step by step. You just like take your first service, and then you just like do a like route, and then when the new request comes, it just goes to the next third, and then just like come back to it. So that's like round robin. This is like really good if like same thing if your all of your like backend services is same. But when you are like creating a backend services, it doesn't have to be same. One service or like one server can be of like little different in size. Like say you usually started with the basic, and then you kind of try to do the uh, vertical scaling, and one server is has like more capacity, and then you started going into the horizontal scaling. Then other two services are in like small size. So in theory, like the first service can handle just like double the traffic than the other two. So that's where this like weighted traffic comes into the picture, or this like weighted round robin. It will still take you from one step to or like one server to the other service, but the load balancer understand, okay, there's like a first service can like handle more, so maybe it will send like 2 requests to the first service, and then it will go to the second and third. but it will also go like one after the other. It will go from one to three, and then it will just like come back to one. And there are like various other algorithms as well. And one of the famous one is like doing the hash or like a sticky session. This like sticky session is like really important when um, your like your like backend services is kind of like stateful, and other two is like really great for it, like stateless, meaning it doesn't have to just like remember about the user traffic or like where the user comes in, where the service will be handled by any underlying service. But imagine if your like service has to know, or you like started a transaction but you're like going back and forth on a same kind of transaction, then you need to like stick your same user request to the same service so that it like knows about your backend. So that time you can use this like sticky like algorithm to make sure this like same request goes into the same backend. So yeah, like there are like various other algorithms as well, but I see that we are like starting with this like round robin, and then this like weighted round robin, and then also like random. That's like great to see here.
Yeah, so meanwhile Srinjoy is implementing the code, I had one question to ask Vijay. Like you mentioned about various algorithm, like round robin, weighted round robin, sticky algorithm. But my basic fundamental question is, how do we decide we need to go for which algorithm as per our use case? How do I decide whether I need to go for the round robin or the weighted round robin? How do I decide that?
Yeah, I think I just like briefly just like touched upon it. It's all about like what is your like services is I mean like how your backend system is architected. Um, I would just say if all of your backend services of your same spec, and it doesn't need to manage a state, like all of your services is like stateless. Again, going back to this like 12 factor application, your backend services, like when you're like defining this like microservice architecture, you try to make the backend system as stateless as possible. And yeah, so when you have a same kind of backend services and your backend services is like stateless, I think it is fairly simple, or like fairly just like a right judgment to go to this like round robin, where you just like spread your traffic to one at a time to the backend services. And weighted round robin is the same round robin fashion, but your services is of like different sizes. So based on your capacity of a service, you assign a weight to each service. Say one server is of 8 CPU, maybe like 16 gig, and another one is 4 CPU, 8 gig. So the first service is just like double the size. So you assign weight 2 to the first one, and then weight 1 to the other two. So the load balancer decides, okay, like the first one should handle like 2 requests, and then the second one has to handle like 1 request. So that's what it is. And the third one is like really important. You can use like two ways, where the hashing algorithm or a like sticky algorithm, however you want to just like call it out, you find out the user from the http layer. Like that's also like difference between this like layer 4 and I mean this like layer 7, right? In the layer 4, you doesn't get to know what is your http option is, like what is your path is, like what is the user is, like what is header, cookie, all those things. You cannot know anything. It just like simply takes it and then just like route it. And with the layer 7, you get the advantage of like knowing about the user path, the cookie, the header, all those things, and then you just like get to know this IP address of the user originated request as well. So by taking the IP address, you can do the hashing, and then you get a value, and then you assign that value to like specific server. That will make sure your like request goes into a same backend. This is really important when like a services kind of like payment services, where you need to keep some sort of a state, and some sort of like I mean kind of like correlation ID, where um, same user request goes into the same backend, even though you are like thousands of just like backend. So based on the use case, based of what you need, or like how your backend systems are like designed, you just like decide your algorithm. And most modern load balancer services from various cloud operations, I mean, gives you option to choose this like different algorithms as well.
Like adding to this, like I had a question about the failure and edge cases. So if a server becomes slow but doesn't crash, so how does round robin handle that first?
Yeah, that's like very insightful, right? So the if you just like simply use the load balancer, it doesn't really care whether your one server is like slow versus the other, right? So all it takes care of is the availability of the service. You just have to get your traffic just like routed to a particular service, and then like get the response going back to the user. So if you simply use the normal load balancer, it does have a health check, but it doesn't check your like latency of the user, this like user request. So it will just like route your traffic. Like that's where like the other feature just like comes into picture. You can put your API gateway and then validates like smartly to understand the user, I mean the user response as well. If like one server kind of not able to handle like a lot of load, your algorithm decides or like keep a track of your like server state, and based on those like performance of the like this like request, and then the heart of the system can decide, okay, so this, I mean like this server is acting up weird, so let's not send the traffic more to it. And whatever the service can handle really faster, then it will like send it back. And sometime like one service like this like user request stays long, and it, I mean it is actually like performing whatever the user asked for it. So then if you just like simply go with this like round robin and then give this like requests to back to the same service, it's not a good idea. So your like load balancer should be smart enough to understand the current capacity of the same server, and then stop sending that like new request to that. And that's the time you can decide your backend architecture to auto scale. It can monitor your services in terms of the CPU capacity, and then just like memory capacity. You can set up a auto scaling in a way that, okay, so if my server reaches maybe like 70% of the CPU capacity and then just like memory capacity, you like spin up the new server, so that your like traffic is kind of like routed to the new one, not bombard the same one and then make it into a crashing state.
That was an insightful explanation. Thank you for that. So,
Alright.
enjoy.
Hmm.
Hmm.
Yep.
So,
So what I've been doing is, let me just complete this. Yeah, AI helped me there. Okay. So what I did is, so this is almost done. Uh, Let me just explain you guys quickly.
right.
So the task was to, like, first of all, we created this config.json file, right, which is the handles all the data of the backend servers the load balancer is currently serving. So let's say backend one is running 710, what algorithm it supports, all those things. We are storing in config.json. And now in the config class, we are creating a config class here, which is like basically validating that particular config and also loading it. And also we have a getter method to get the particular config.json also. So that's how like the load balancer knows like, okay, for this backend, we have to process it in this way. It is in this port, it will use this algorithm, so and so. So we define these interfaces. This is the backend server configuration, which contains the domain and the weight. This is the interface config. This is the port, load balancer algorithm it supports, and the fleet of backend server it supports. And this is the export class, and this is the validation layer here. We are like validating that port. So you see that this level of strict validation we are supporting, so that LB port is a type of port, not just like 123. It should be like 3000 or 8081 or 7010 something, like logical to ports. And the load balancer algorithm, we are supporting grand round robin, weighted round robin, which is a compulsory data, and fleet of backend servers, which with domain and weight as like compulsory fields. And we have a method in this config class as load. This is for loading this particular config.json, whatever config.json we have. So we are just loading it. We are like resolving the path of this from the config path. We are loading the text in a like good manner, like streaming the text in an object, in this raw object, and we are parsing this raw object in JSON, and we are validating that okay, that raw object or whatever config that is like valid for our load balancer class or not, and then we are setting that value. And after that is done, we have another method also, that is the getter method to get the config. And now we are using this config here to basically load this particular config here, whatever this load is doing. We saw that it is like getting the config, parsing it, validating it, and setting that particular config for that particular load balancer. And this is the it is like getting the config, that const config goes to config.get config, which gets that particular config. And for that load balancer port, I replace the config with config.lb port, which refers to this particular port of load balancer. And this is, yeah, so this is basically the step two. And to verify, I have removed the port 7010 hard coded, and now we have this config.lb port. So let's try out if it is showing 7010 or not, because LB port is 7010. If it shows in the local, then I think we are good, right? So let's see. Yeah, it does. So we are fine. Let's go and push the step.
Hopefully this time it passes.
Yeah. Okay, nice.
So if I'm just
Um,
like kind of understanding, so you're like doing a development based on the steps it is asking you to do, and there's like success criteria I can see. You have to make sure you're implementing to like satisfy all this. There's like success criteria, and hopefully it is like thinking from various angle or like various like engineering principle, and you are like developing a code and you are pushing it to a GitHub. I think that is also like mimics how this like enterprise team works. And
exactly.
when you're pushing it, I think the backend system takes the code and then execute the test cases which the platform defines, and it has to pass all the stages. And if you pass, then you're getting just like congratulations, and then you just like completed
Mhm.
that step and then going to the next step.
Yeah.
um yeah, that's like a real way to just like develop something, just like rather than not watching like tutorial or just like reading about it. And the more you do and you make mistakes and then you like debug it and then you learn from it. And I hope like this will be like really interesting to see during this like interview as well, because you actually did it by like following a step.
Mm.
And you can use AI here, but I would highly suggest not to use AI, because you're just like understanding, or like first like understanding this like requirement, and then your brain has to think about, okay, like for this requirement I have to choose this versus that. And then from there again, while you're doing it, you just get like a lot of interesting ways to solve it, and more you solve it, it's more of a gaming, right? So you,
Yeah.
the more you practice, you just like win the game more. So while you're doing it, it kind of like register in your brain. And then during this like interview, often people ask, hey, like did you like build anything like these days, right? So you can
Mhm.
honestly like tell this as like like many of the students will say, hey, I just like did this one like POC for this like web application, or maybe you just like added a button or like added a screen. But like here I can see that you're like actually going into the core and then like building the load balancer, or like creating your own load balancer, and then if you explain that step to the interviewer, and then what is the pattern you followed, and then how did you approach it, and then try to explain like various algorithms and various stages. I think that's a great way of like showing out there, and I believe this like code is getting recorded into your like personal GitHub repositories as well, and those
Mm.
stars and those achievements really makes a difference uh, in the actual like interview as well. And it's great to see all things just like put in together.
Yeah, right. So yeah, like as you mentioned, like in today's world, like if somebody has like built their own load balancer, and for example, they have this thing in their resume that I've built my own load balancer and I have deployed one application which is a CRUD application, and my load balancer serves those backend fleets for as a load balancer there rather than using a different service. So it is like, to me it is like very impressive that okay, you made your own load balancer and made another separate project and serving those backend instances as a load balancer. So that's pretty great. So yeah. Moving on to the third step. So the third step is basically state is the enemy of simplicity, but necessary for a load balancer. We need to track the state of each backend server. Okay, so we have to, in this step, what is demanding is that now we are moving on from raw config, that is like the objects we created, like the config class we just created, right? This thing, and we just hard coded the config.json here, all these things. So now we are moving on from the raw config objects to like runtime backend entities with state. So like, will the backend be healthy? How many requests has it handled? What is the weight of the backend? Like weight meaning, like weightage meaning like priority, right? Like which priority it should get basis on the round robin or the weighted round robin. Um, so what this step is demanding is it like we have to create a backend model that stores URL, weight, this thing, the health state, and like the request counters, how much request it has handled, all those things, right? And technical meaning being routing and health logic needs like a what do you call that, a muted state. Like classes give us a clean place to store and update it, so that in a modular monolithic structure it is like preferred to build a lot of classes and use those as objects and make interfaces and make those classes get implemented by it. So that makes a like good clean modular monolithic structure. So for this step we will have a simple analogy, like for example a dispatch board is there, right? For example, there is Uber and there is a dispatch board, like which driver is available or not, or going where, all this information it has. So same goes for load balancer. The load balancer also has the dispatch board and have this kind of data for it. So once backends are modeled properly, routing algorithms become straightforward. So after this step, it is like all this like core logic of load balancers come into the place, where like all the uh, load balancer algorithms and routing logic and retry mechanisms, resiliency patterns, all this takes place. So moving on to this thing. So let's see, we have to define server health enums. Okay. Okay, let's go step by step. Let's first, define the enum. We have to define the possible states of a server, healthy versus unhealthy. Healthy versus unhealthy, I'm hoping we have to define two states here, healthy and unhealthy. So let's quickly create that. Let me close this window. Yeah.
Yeah,
One second.
meanwhile, Srinjoy is implementing the step 3. I had this very trendy question to ask to Vijay, considering his expertise in building scalable architectures and in real world enterprises. We have seen in this era of AI, we see everyone is labeling them as an AI engineer, AI ML engineer, and including AI in every sort of job title they are getting, right? So, what do you think what it takes to be a good AI engineer in 2026?
All right. That I mean that's like very interesting question, and again, as I said, like AI being very hot in the, hot in the industry. Like earlier, maybe like few years ago, there are like few AI engineer like specifically titled, and then other domain people are just like figuring it out, like what the heck is going on. But now that things are changed, every software engineer is almost like they are claiming themselves as a AI engineer also, and that is like very fair because they can now write a system prompt and then create a wrapper and then simply call the backend LLM and then add that AI capabilities to the existing software. And being a software engineer, you get the edge. Like you already understand this like system, you already understand your like business knowledge, and then now it is so much easy that you are just like creating a wrapper services for your AI and then adding that layer into your system. But then what is the this like real difference between the AI engineer title versus like a normal software engineer, right? So I'm just like keep repeating this to all the people where I'm just like talking to. Do not focus on creating a simple wrapper. Do not create another like ChatGPT kind of version, and then you can tell it like, hey, you can just like create like a beautiful system prompt, and then you can like create a beautiful user prompt, define a system, and then call yourself as a AI engineer. And then people ask me, okay, so if I know like a RAG, does it just like cut to it? But I would say is like building a RAG solution is like hello world of the AI engineering. Um, you can go to any YouTube video, and then when you start with this like AI engineering, so they just like talk about, okay, so they will start with the prompt engineering, then go back to defining like your like wrapper services, and then go on like handling your like RAG services. So if you stop there, and definitely you cannot get a job because every software engineers are already familiar with it. So now you need to think more than that. um, so I can just like give like few pointers where you need to like really focus, right? Again, like the AI engineers is also kind of like engineers in a way that, but like they're like more familiarized with the AI concepts. So your core engineering skill is really important. You need to still think in like system wise, say what model you choose, and like what if this like model goes wrong, and what if this like like the AI latency increases, and what sort of tool you use, where should you allow the human in the loop, and how do you handle the fallback mechanism, how do you stream your services, and what scenario you need to just like respond quickly versus your like stream your services, and how do you define your service. And you can like develop your app in your like local, but from local to just like getting into just like production, right? And also like how you architect your AI app. Don't just like always like think about, okay, I can write a good prompt and then my backend LLM will just like take care. But that's not the real AI engineering power is. So you should think from an AI architecture like perspective. You should like think from like pipeline standpoint. Okay, so you get your like user request, and what is the guardrails you're just like putting in. How do you identify this like intent of the user request? How do you manage your memory? Just like RAG, right? Like RAG is like one of the item, and like these days there are like so many ways of doing a RAG. How do you just like embed it, just like chunking, all the way to like creating this like index, like RAG, and like there are like so many like techniques just like involved. And also, how do you define your tool? What model you choose, and then do you use like reasoning model? Do you use like this like large language model versus like small model? And you kind of execute your tool, and also doing this like verification, and then like finally just like responding, right? So you should not think from just a prompt engineering perspective. You should really think about like how your like pipeline goes. And other than that, like there are like various aspect to it, right? If you want to be like a really good AI engineer, uh, as I said, you need to like worry about your like token context. There's like memory layer into it. How do you evaluate your AI like pipeline? If you're not able to do the eval, you cannot improve it, right? There's like saying, right? If you cannot like measure it, you cannot improve it at all. So how do you create your harness to it? And there is other factor to it, like there's like a data engineering factor to it, right? So your AI is as good as your data. So how do you manage your like data efficiently? And these days this like security has to be like second nature when you're like building AI, right? You can easily do this prompt injection, or they're like there are like so many like vulnerabilities like or added into like a lot of like common just like libraries and then like patterns to it. So you can easily like spoof your request and then do a serious damage to your like backend system, where it can like delete your code, or it can like expose the entire database. So my like point is, if you're stopping at just being creating a wrapper and then using your AI to like build your system, you are not cut for this time. At least at this time, you need to know about like going into a simple prompt engineer to like defining your system well by using all the tools and services. So everybody should ask, okay, um, like if you're given a challenge, instead of what prompt should I write, from what is the system I should architect, and how do you package it, and how do you deploy it. If you are taking care of all those things, I think you can really stand out from all the crowd.
I mean, that was a really practical advice which we got for you, got from you, and I think it's highly relevant considering today's time, because we see that people are writing AI engineer in their resumes, but in the reality, they are just kind of mere just prompt engineers, and the AI might be loud, but the basics are still louder. Like we still can't ignore the fact that math is the basic foundation of AI or ML modeling. So if you're not able to understand the maths of AI, like when I talk about maths of AI, it means statistics, probability, hypothesis testing, and other various topics. These are the mathematical topics which help us to understand any AI ML algorithm. And when we know about the deep insights of the algorithm, we are able to get to a conclusion, as in depending on the use case, which algorithm or a model to go for, instead of just creating a wrapper. Because just creating a wrapper doesn't make you an AI engineer. What makes you an AI engineer is thinking about the trade-offs. How do you handle the API limit? How do you work on saving the token cost? And let's say, like you are talking about RAG, right? You mentioned that RAG is the hello world of any AI engineer, right? So when we talk about RAG, what people think is RAG is just retrieval embedding an LLM. But in real world, in a real production grade environment, RAG is more than that. Like when we talk about retrieval, the basic of retrieval is that again here data comes. You also talk about the importance of data in any AIML model, and that's where data engineering comes in. So for a RAG, the data is acting as a source of a truth, and when we are using any data for our RAG application, chunking is used. So chunking is basically makes our data ready for to be used for the RAG. So we just can't use any sort of chunking, or let's say if we are using AI, then AI will draft any random chunking just on the basis of the prompt. But chunking is more than that. Depending on the document, you are going to choose the relevant chunking strategy. Like suppose you have a medical document, right? Chunking will happen based on the problem wise, and then based on that, the RAG model is gonna work, because the quality of the response which the RAG is gonna generate depends on the quality of the data. So I believe, I think we need to still focus on the basics, because the AI hype may be loud, but the basics are still louder, and that's what it's gonna differentiate from the huge crowd of people who are just labeling them just as an AI engineer. Because when it comes to building production grade systems, their code breaks down. And one of the major fallback of AI generated code is that like you can't use it in real world environment, and it's very hard to debug. And people might be using AI blindly. So like for any enterprise grade application, you can't use AI blindly, because for just a minor change, it might change multiple lines of code, and then you might be knowing which change is happening in which file, and then when someone asks you to explain the code from the very basics, you go just blank. So again, like emphasizing on, yeah, Vijay.
Yeah, I think yeah, like that's like a great insight as well. And then I would just like add like one point, and then we can go back to like Sinjay. I think he's like wrote a code, right? I will always think like whether it's like software engineering or the AI engineering. Like I think like these days the agentic coding has like become quite mature, and then it can like based on your prompt and then what you're asking it to, it can write very well code. But the big difference is like after you write your code, where your brain goes uh, I mean, just like satisfying all the happy parts, and then that's where those like system or just like solutioning is like really, I mean, important, right? If you are just like thinking in that sense, you are already well ahead of it.
Thank
Yeah,
you. Over to
completely
you,
agree.
Srinjoy.
Yeah, so as the step 3 demanded, we make our server here like the backend states, like what are the backend server details are. So we had to make a backend server details class here. First of all, I made a backend server details interface, which is like the URL, the server weight, the status of it, the set status, and the increment request serve, which is a method, and reset metrics is also a method. And this is the class here, which is this. These are the variables, and we have the constructor where we are setting the URL and the server weight on startup of the class, and we have some getters and setters for getting the status, setting the status, and we are like once the request is served, we are incrementing the request. That's how the load balancer knows that okay, this backend has served this much request. That means it makes sense to the load balancer. Okay, this backend is serving some request, means the load balancer is sorry, the backend server is in a steady state, right? So we are incrementing the request served count, and we are also like making the reset metrics to 0 after a request is served. And after this is done, the index.t is done. Sorry, the backend server details class is made. We are just simply initiating the backend servers by mapping into the backend servers and making an object of it by passing in the domain and the weight of the particular backend instances. And yeah, while in port for this particular step, we are just passing like okay, this load balancer is running on this port, and the algorithm is this algorithm, and the initialized backend servers is backend servers dot length is this. So, and if we try and test it out, we should see all these things. So we see the port is running on 7010 and backend servers are 2. If we go to config.json, backend servers is 2 right here. There are two objects, this and this, and port is 710. And RR algorithm is the round robin algorithm the load balancer is using currently. So so I guess we are done with the step 3. Let's try to push and let's see if KodeMaster takes our solution or not. Yeah.
That's great. You're, I mean, just like getting past at the first attempt. You might have practiced a lot.
Okay. So the
uh,
step 3 is done. And I guess like
all right.
people, yeah, I guess people can go and try out the rest of the steps by also like this build out the entire project challenge. And I think uh,
Do you want to like quickly show like what are all the steps involved, like overall, like how many steps and like what did get to have the entire project ready and what are all the steps it involved?
yeah. So okay, I have to reshare the screen to go to that tab. Let me do that quickly. Um, Let me find the tab. This is the tab window. Yeah. I hope the screen is visible.
Yeah.
So as we saw, like this, all the steps got we passed, and we are on this fourth step right now. That is the HTTP resiliency of the HTTP client, and there are until 20 steps. Like the steps being the load balancer class. This is like the load balancer class we were going to be implemented where It is like making the load balancer generic, and it can handle all the backend servers objects and do all the routing stuff. And then we move to routing basic. Like, we first of all, in the sixth step, we make a basic routing, like how reverse proxy works. It gets the request, finds out the backend server, and passes the request back to the backend server. That is the simple routing basic we are doing. And from seventh step onwards, we are going into the core load balancer logic, like making different algorithms, like running those routing logic with those algorithms. And yeah, then round robin comes into the place. Weighted round robin comes into the place. Then we are doing some resiliency stuff here, that is health check pass, periodic pings, managing healthy list, passive health checks, retry logic. And also we are making a CLI for the load balancer, which is like, load balancer is there and your backend fleet is there serving request by with the help of load balancer. Your CLI can actually, you can just run a command and see, okay, like my backend fleet's status is this. So that is also a helpful tool. That is a CLI for a load balancer, and we are handling graceful shutdown, TLS termination, Dockerization, which is like dockering the entire fleet together and deploying all together. And we're also doing integration testing at the 19th step. And at the 20th step, we are doing final review and documentation of the project challenge. And yeah, then you will like earn the certificate of completing this amazing project.
That's great. I mean, I can see that it's like no more like vibe coding or like creating a toy project. You're like thinking from a various angle, like how the actual just like industry works. And I believe like whoever gonna follow the steps and then just like complete this, they will get like one thing, they will get like satisfied that like they just like built like a just like core component of the any architecture by themselves, and hopefully they will get this like industry experience, and then they'll be able to perform well during the interview. It's amazing to see like everything just like put together.
Hmm. Well,
Yeah.
Vijay seems to be highly impressed by CodeMaster platform. So, just asking you one question: are you gonna try our platform after this live webinar, this project challenge which
Yeah,
we have?
absolutely. I mean, I've been like using the load balancer just like left and right in my system architecture. Now I think it's like right time to go back to the basics and then understand like what is like internally happening. And this platforms gives me really kind of like structured approach to starting from basic and then all the way to like just like containerizing and then just like deploying your applications, right? So I'm gonna like definitely try it out.
Hmm. So, like adding to this, like since this Srinjoy has just implemented 3 out of 20 steps, 17 steps are still building. There is a surprise for all the participants that whoever completes this whole project challenge within the next 24 hours, that person will be eligible for a big surprise. And that surprise is a surprise. So, in order to unveil that, pull up your socks and complete this project challenge within the next 24 hours to unlock that prize. So, with this, we come to the end of this webinar. And like before we end, I just want to say that don't stop at building features. Start asking the why of building the features. How are we implementing that? Why is a particular feature really needed in building a system or to make it production ready? Because that's where the real growth begins. And now it's your turn to make your path more smoother. Go and register for the Build with Codemaster AI hackathon to fulfill or let's say utilize the month of March and contribute to your professional upskillment. And with this, we come to the end of this webinar. So, I mean, thank you so much, Vijay and Srinjoy, for all your time and great insights. It was a great webinar, and like I was also able to get a plethora of knowledge about load balancer, the architecture of load balancer. So, thank you so much for your time, guys.
Yeah. Likewise.
Yeah,
Pleasure to be
it's
here.
very yeah, I mean, great to just like talk with you guys. And then even for me, like even after this like 20 years, I'm like still always like learning, and this is like definitely a great experience. for me as well. And like, thank you so much for all the insight, guys. And amazing to see like how this is all like shaping up.
Thank you so much. With this, we come to the end of this webinar. So we have another, like some more webinars also lined up in this Build with KodeMaster AI Hackathon series. Make sure that you like, share, and subscribe to our channel. And don't forget to participate in the hackathon. And don't forget to complete the project within the next 24 hours to unlock that surprise. Thank you so much. That's been your host, Divya
All right,
Tripathi.
guys.
Thank you.
Thank you. Bye.
Okay.